video for the 240 automotive class on O2 sensors and some of the faults. We're going to be doing this on a 2005 Chevy Tahoe that does indeed have the 5.3 V8 in it.
Okay, so we pulled up a diagram or picture from ALLDATA to get a better representation before we showed it on the actual car. On the right side right here is going to be bank 1, left side this is going to be bank 2. So up top this is going to be bank 1 sensor 1, which is this O2 sensor right here. And then after the cat it's going to be bank 1 sensor 2, which is this O2 sensor right here. And then for bank 2 this is going to be the sensor 1 for that one. And then after the cat it's going to be the sensor 2 for bank 2 right here.
Okay, so we are now underneath the car. We're going to start from the back of the exhaust and work our way forward. At the very back, on the farthest one, is going to be our O2 sensor here, which is going to be our bank 2 sensor 2, which is after the cat. Working our way forward on bank 2, we're going to have our second sensor, which is going to be this one up here, which is before the cat, which is going to be bank 2 sensor 1. Then on the driver's side, we're going to have our sensor here, which is after the cat, which is our bank 1 sensor 2. And finally, we're going to have our bank 1 sensor 1 cat here before the cat.
Okay, so basically to get a better look at what we got going on, I have a hand-drawn schematic for the O2 sensor. Currently we have everything hooked up as far as our Pico and DVOM to bank 2 sensor 1. So this is the schematic I drew. For our schematic on ALLDATA, the sensor 1 for both bank 1 and bank 2 share the same fuse up in the fuse block. So down over here I didn't draw it, but this is bank 1 sensor 1 over here. Over here is bank 2 sensor 1, so this is what we will be using. To start at the top in the fuse block, power's coming through the fuse block and it is going straight through a fuse. It then comes down and separates to bank 1 sensor 1 and bank 2 sensor 1. So both sensor 1 and sensor 2 will share one fuse. It's going to go into a connector and then go into a resistor and a variable resistor. From here, this goes straight into the PCM with a switch down here. Down here, it's going to be the O2 low control. It'll then go and gets transmitted its signal through the PCM. The PCM will then send the signal out to this variable resistor back to the O2 sensor. This variable sensor is going to depict what voltage it's going to read as far as the mixture ratio that is going through the exhaust system. Once this signal is kind of transmitted, it'll then run out of this sensor and back to the PCM, where we also have our low signal and high signal for bank 2 sensor 1 for the O2 sensor. To further talk about the sensor, currently the sensor we are using and have our DVOM hooked up to, it is a zirconium sensor, which is a narrow band sensor. Our sensor has 4 wires in it. Signal low, which is going to be this wire here coming out of the PCM, which is tan colored. We have a signal high wire, which is purple and white, which is this sensor right here, which is coming out of the O2 sensor back into the PCM. We have a heater low sensor, which is right here, and then we have a ignition voltage sensor, which that one's going to be colored pink, which is coming straight out of the fuse box down into the sensor. So right now we are about to take off the PCV hose to create a system vacuum leak fault. Immediately you can hear the car rev up. We go look at our DVOM and multimeter. It seems that they are sitting at very low voltage, and every now and then, about every 2 to 3 seconds, the voltage spikes up. Same thing on the scan tool. We're reading 0.8 to 0.9 volts, and then it'll drop down to 0.02 volts. Okay, so currently we still have the PCV hose slash valve unplugged. Short-term fuel trim is currently at a steady 51.6%, which is a lot. It's dumping a lot of fuel in there. Long-term fuel trim is at 25. We have seen long-term fuel trim jumps up right away as soon as we create a vacuum leak. But now we're gonna test it to what happens to short-term and long-term at 2,500 RPMs. So right now we're gonna see the short-term fuel trims probably slowly rise back up to 51. We just saw long-term fuel trim drop down to around 10. It then jumped immediately back up to 25%. Main reason for this is because while the engine is increasing in RPM, it's really wanting more air. So with that vacuum leak letting a lot more outside air in, the engine doesn't mind that, so it's needing less fuel.
You can also see on the picoscope that the car is running very lean with that vacuum leak in place. On our picoscope here, you can see the graph on normal operation. What we're seeing is the voltages dropping and spiking between about 0.06 volts and 0.95 volts. It is doing this because the oxygen levels in the exhaust are raising and lowering as the O2 sensor tells the engine to add or subtract fuel from the mix as it currently is to try and get the engine to run at the stoichiometric ratio.
Okay, so we are currently going to do a fault for our bank 2 sensor 1. We are going to unplug a connector from one of the ignition coils. Currently we are at normal operating temperature, there's no vacuum leaks, and everything is connected right now. We are going to go ahead and unplug an ignition coil and look at what the voltage does and what short-term and long-term looks like. We just unplugged on the ignition coils. We did see a drop in voltage immediately. Short-term fuel trim is kind of changing. Long-term jumped up to 25 immediately. We had the ignition coil unplugged for about 5 to 10 seconds. With the ignition coil plugged back in, long-term fuel trim still at 25, but our short-term fuel trim dropped back down to close to 0. Right now it's about a -2 to about 0.8 volts, or sorry, negative 0.8 volts. Voltage on the digital multimeter is back to normal operation. It's jumping from about 0.05 to about 0.9. The next fault we're about to do is by creating an injector misfire by unplugging one of the injectors. Right now we're at, again, normal operating temperatures, and everything is plugged in. Okay, we just unplugged one of the injectors to create a misfire. Right now our DVOM is reading a constant 0.01 volts, and same thing for our scan tool. Short-term fuel trim is 0, long-term fuel trim is also 0.
On this vehicle there are quite a few codes. Some of them are from modifications to the exhaust, along with some modifications to the intake and some problems with the evap system, but we're going to go through all of the codes that are on this vehicle. First we have a P0054 code, which is a O2 sensor on bank 1 sensor 2 heater resistance fault. We also have a heater resistance fault for bank 2 sensor 2. We also have a P0102, which is a MAF or VAF A circuit low input. We also have a P0141, which is a O2 heater circuit malfunction for sensor 1/2. We next have a P0157, which is an O2 circuit low volts for sensor 2 on bank 2. We then have a P0161, which is a O2 sensor heater circuit malfunction for bank 2 sensor 2. We then have a P0200 for an injector circuit open. We also have a P0300 for a random multiple cylinder misfire detected. We also have a P0443, which is an evap code, and another evap code, which is port P0449. The multiple cylinder misfire is from when we undid the ignition coil for our one test, along with the fuel injector setting off a code. And all of the codes for sensor 2 on bank 2 are set off because of the fact that the O2 sensor for bank 2 sensor 2 is the wrong year for this vehicle, so the plug is does not fit correctly and is not connected to the right pins.